Hi. Today we're going to talk about solving differential equations. And so an equation involving a derivative is called a differential equation. A differential equation in the form in dy over dx is equal to f of y times g of x is called separable. And so essentially what's happening, sorry about that, what we're doing is if we take the derivative, let's say of a circle of x squared plus y squared is equal to 25, okay, we call this implicit differentiation. And so you're going to get 2x plus 2y dy dx is equal to 0. Well, what we're doing is what happens if I want to take the antiderivative of these? How would I do that? And that's what differential equations does. And so what it does is it undoes, I guess if you want to say it that way, implicit differentiation. And so I have several steps set up for you to help you solve differential equations. First, you need to separate the variables. The second step, you need to integrate both sides. Please put c with your independent variable. Typically, it's going to be x, but it also could be t. 3, if there is initial condition, please go ahead and substitute that in and solve for c. And our last step is then we're going to solve for y using our c. So let's look at several examples. Alright, for the first one, find a solution where y is equal to f of x to the differential equation dy over dx is equal to 3x squared over e to the 2y, satisfying that f of 0 is equal to 1/2. This is going to be your initial condition. And so let's go with our first step. Our first step is we need to separate our variables. And so we have dy over dx is equal to 3x squared over e to the 2y. Well, I want my x's to be together, so I'm going to multiply my 3x squared and my dx. Essentially, I'm multiplying through by dx. I want my y's to be together, and so I'm going to multiply my dy times my e to the 2y, and so I'm going to multiply through. And so if you want to think about it, it's kind of saying we're working with this cross products. So we have dy, so let's go ahead and multiply e to the 2y times dy. So that means it's going to be e to the 2y dy. And that's going to be equal to 3x squared times dx. Our second step is going to integrate our separated variables. So we're going to integrate e to the 2y dy. And we're going to integrate 3x squared times dx. Well, the antiderivative of e to the 2y is e to the 2y, and then I'm going to divide by my coefficient in front of my y, and that's going to be equal to x to the third plus c. Next, we're going to use our initial condition to solve for c. So that's our third step. We're solving for c. So we have e to the 2y over 2 is equal to x cubed plus c. So if I plug in 0 in for x and 1/2 in for y, I'm going to get e to the 2 times 1/2 over 2 is equal to 0 cubed, which is just 0, plus c. So c is going to be equal to e to the 2 divided by 1, or 2 times 1/2 is 1, so it'll be e to the 1 over 2, or e over 2. So our equation is e to the 2y over 2 equals x cubed plus e over 2. Our fourth step is now we need to solve for y. And notice our y is in the exponent. So the first thing I'm going to do is I'm going to get rid of the denominator. And so I'm going to do that by multiplying through everything through by 2. So that gives me e to the 2y is equal to 2x to the third plus e. Well, now I'm going to take the ln. In order to get to the exponent, I need to get rid of a base e, and I do that by taking the ln of both sides. So we have the ln of e to the 2y is equal to ln of 2x to the third plus e. Well, anytime I have an e raised to an exponent, I can move that exponent to the front. That's part of our log rules. So I have 2y ln of e is equal to, and we can just leave this the right hand side, ln of 2x to the third plus e. We'll just leave it as it is. Ln of e cancels, and so I'm left with 2y is equal to ln of 2x to the third plus e. Now I can divide both sides by 2. And so my final answer is y is equal to ln of 2x to the third plus e divided by 2. Alright, number 2, if dy dx is equal to 2y squared and when y is equal to negative 1, x is equal to 1, there's our initial condition. Then when x is equal to 2, y is equal to what? And so again, we're going to do our first step. So first step, we're going to separate our variables. So we have dy over dx is equal to 2y squared. And so I'm going to move my dx to the other side, and I'm going to move my 2y squared underneath my dy. So essentially I'm multiplying across. And so that gives me dy over 2y squared is equal to dx. Alright, number 2. Now we're going to integrate. And so I have 1/2. I'm going to move the y to the top so it becomes to the negative 2 dy is equal to the antiderivative of dx. And so the antiderivative of 1/2 y to the negative 2 is going to be 1/2 y to the negative 1 divided by negative 1, so that means this becomes negative 1/2 is equal to the antiderivative of dx is just x, so we're going to write x plus c. And so now I'm going to plug in my initial condition. So I have negative 1/2. I'm going to go ahead and move the y back down because it's to the negative 1 is equal to x plus c. I probably should have wrote this in red. Alright, so y is negative 1. So we have negative 1/2 times negative 1 is equal to x is 1 plus c. So we have 1/2 is equal to 1 plus c. So if I subtract 1 from both sides, c has got to be equal to negative 1/2. Sorry, I forgot to label this. This is step 3 when you solve for your initial condition. So that means my formula is negative 1 over 2y is equal to x minus 1/2. So now I need to solve for y. So I have negative 1 over 2. Negative 1 over 2y is equal to x minus 1/2. Again, I'm going to get rid of my denominator, so I'm going to multiply through by 2. Actually, I'll multiply through by negative 2 so I can get rid of this me do it a different way. Since my coefficient in front of my 1 over y is negative 1/2, I'm going to multiply by the reciprocal, which is negative 2. So that means I'm going to multiply the other side by negative 2. I think that's a little bit easier way of explaining it. These two will cancel, so I have 1 over y is equal to negative 2x plus 1. And so now that I have a 1 over y, I want to use the reciprocal. So I'm going to take the reciprocal of 1 over y. That means I need to take the reciprocal of negative 2x plus 1. Take the reciprocal of that. So I'm left with y is equal to 1 over negative 2x plus 1. And so now I know what x needs to be. The x is supposed to be 2. What is going to be y. So if x is 2, that means that y is going to be 1 over negative 4 plus 1, which means y is equal to 1 over negative 3, or negative 1/3. And that's our answer.